let us start it with a new chapter today. Is about the cycloalkane. As you know, the hydrocarbons can be founded as aliphatic hydrocarbons, okay, acyclic compound, open chain, or with cyclic compound. So the reactions, some properties is like alkanes, okay? But here we will talk about cyclic alkane. We will focus about the properties and the stability of the cyclic compound, okay? Here, the properties and the stability of the cyclic compound. Many compounds are cyclic, yes. They contain ring of atoms, ring with many atoms, with the 3 atoms, 4, 5, more than 5 atoms, okay? So the hydrocarbon we eat are cyclic. Some hydrocarbon we eat are cyclic. The nucleides that makes up of DNA, RNA also, they are cyclic compound. And some antibiotics, they are also cyclic compounds. And many drugs also has cyclic parts, okay? So in this chapter, we will focus about the properties and the stability of the cyclic compound. We don't talk about the reaction of the مثلا cycloalkane. For example, the halogenation, the mechanism of the halogenation, as you know. No. We will focus about the properties, some properties, and the stability of this compound, okay? So, cycloalkanes have molecular formula CnH2n and contain carbon atoms arranged in the ring. Okay, this molecular formula is like what? It is like alkene. Okay, why it is like alkene? Why it is like alkene? Why? What do you think? Okay. Remove 2 hydrogen to make a new bond between carbon and to make cycle. Yes? For example, if you have this compound, this CH2 ethane, CH2 CH3 methane, ethane, propane, butane, pentane, okay, and hexane. So if I want to make this compound in cycle here to close this with this, that meaning I have to remove 1 hydrogen from here and 1 hydrogen from here, okay, and make cycle. It will be like this figure. It will be cyclohexane. That means cyclohexane ordinary to remove -2 hydrogen, okay, -2 hydrogen to close the ring, okay, to close the atoms together in cyclic figure. Do you understand? So, and contain carbon atom arranged in a ring. Think a cycloalkane been formed by removing 2 hydrogen. It will be right here by removing 2 hydrogen from every end. This hydrogen and this hydrogen. Remove from hydrogen from here and remove hydrogen from here. And then bonding the 2 carbon together to make cycle, like this figure, okay? So, cycloalkane having a 3 to 6 carbon atom are showing in this figure here, like this. 3 carbon atom, we know it will be propane, yes? But cyclic, it will be cyclopropane. And butane, cyclobutane, cyclopentane, and then cyclohexane, and then more than cyclohexane, okay? More than atoms. It is clear for you? Okay. Now, how we can use IUPAC system to give name for this compound? Actually, IUPAC system, it is not new for you. I think it is also so easy for you now. So, at beginner, step number 1, he said count the number of carbon atom. How many carbon atom in the cycle? Okay, and just in the cycle, not with the other atoms. Yeah, don't say 1, 2, 3, 4, 5, 6, 7, 8, 9. No, just the cycle. Okay, the number of the atoms that contain inside the cycle. So, and added the prefix cyclo and the suffix and to the parent name. So if you have hex, it will be what? Hex, yeah, that means 6 carbon atom. It will be cyclohexane. Chinko, why? Because it is, yes, it is saturated. Okay, because it is saturated compound. If you have, for example, double bond here, it will be cyclohexene, but it is not our subject now, the alkene. We just talked about the cycloalkane. They are saturated. So, number 2, name and number the substituent. Okay. No number is needed to indicate the location of single substituent. For example, this cyclohexane, and here we have methyl, it will be methyl cyclohexane. We need put number 1 here? No, why? Because just one group, one substituent on the cycle, okay? We don't need number 1. Don't say 1 methyl cyclohexane. We don't need number 1. Already it will be at position 1 already, because you have here just one substituent. Okay, what is the substituent here? Any substituent? Pentane, but any pentane, normal pentane? Yes, it will be tertiary pentane. For this reason, tertiary butyl cyclopentane. Okay, tertiary butyl substituent on the cycle, butyl YL cyclopentane. Okay, don't forget this YL, because YL now is substituent. Okay, alkane, when the alkane will be substituent, it will be what? Alkyl. Okay, alkyl. Is it clear? Okay. Now, for rings with more than one substituent, if you have more than one substituent, begin numbering at one substituent and proceed around the ring clockwise or counterclockwise to give the second substituent lower number. We know this, yes? For example, we have here 2 methyl. Okay, where is methyl? Both of them identical. There is no difference. Put this number 1 or this number 1 and start to number the carbon atom. For example, this methyl here, take number 1. Okay, I will go 1, 2, 3 or 1, 2, 3, 4, 5. 1, 2, 3. Yani according to the clockwise. Why? Because the second substituent, it will be take lower number. Okay? 1, 3. It is, yes, 1, 3 dimethyl cyclohexane. Okay? Cyclohexane. 1, 3 dimethyl cyclohexane. If you go like that, 1, 2, 3, 4, it will be 1, 5. Look, second substituent, take number 5. It is not lower number. This is the best one. Take lower number. Okay? Take second substituent, diamond, take lower number. Is it clear for you? Okay. Do you have a question? Okay. Let us go to the second example. Okay. With 2 different substituents, this is identical substituent. With 2 different substituents, like methyl ethyl. Number the ring to assign the lower number to the substituent alphabetically. So this methyl, it will be start with the M, and with this ethyl, it will be start with E. Okay, alphabetically, anyone, it will be, yes, it will be E come first. That meaning it will be this take number 1. Okay, this, it will be take number 1, and 1, 2, 3, or 1, 2, 3, 4, 5, 1, 2, 3. Okay, according to the clockwise, because the second substituent take lower number. Okay, do you have a question? No question. So the answer, it will be what? The answer, it will be what? 1 ethyl, 3 methyl cyclohexane. If you go like this to put 1, 2, 3, this is incorrect answer. Khalat. Clear? Do you have a question? So, this diapack system, when an alkane is what? Is composed of both ring and long chain. Okay? That meaning we have cyclic compound, but we have substituent on the cycle compound with open chain. Okay. What determine whether the compound is named as acyclic alkane or it will be cycloalkane? What meaning that? Yeah. What meaning here? Meaning here, if you have cycle and you have open chain, substituent on the cycle. Okay. Anyone, it will be the parent part. Okay. The cycle or the open chain. A. Yes, yes. Okay. Another answer. The chain. Okay. Depended on what? Why you? Yes. Yes. Depended on the number of the carbon atom. For example, this. Where else? We have example here. Okay. Another example here. For example, this cyclohexane. Okay, cyclohexane. Now, if I put methyl here, okay, the parent part, yani dicobab, okay, but it will be the cycle. Why? Because the cycle have 6 carbon atom and the substituent have 1 carbon atom. If I put like this, also the cycle it will be the parent part. Okay, ethyl cyclohexane. If I make like this, propyl cyclohexane. If I make this, butyl cyclohexane. If I make this, pentyl cyclohexane. Also, the cycle has 6 carbon atom, more than 5 carbon atom. If I make like this, hexyl cyclohexane. If the both of them the same, also you have to select the cycle. Okay, also you have to select the cycle. It will be hexyl cyclohexane. If you have this, pentan, cyclohexyl, pentan. Okay, where is the cyclohexyl at carbon number? 1 cyclohexyl. Okay, 1 cycle. That meaning now in this case, this it will be the parent part. Okay, this it will be the parent part. Clear for you? Okay. So here we have ethyl cyclobutane. Don't say cyclobutyl ethane. It will be incorrect. Okay, it will be false here. Tamam? So look here. Secondary butyl. Look here. Methyl and we have secondary butyl. Assign the lower number to the first substituent alphabetically. Okay, that meaning B, this the butyl. Okay, before the M, B, before the M. That meaning this it will be take number 1. Okay, 1, 2, 3, 4, 5, or 1, 2, 3, 1, 2, 3. That meaning the methyl at position number 3. It will be 1 secondary butyl, 3 methyl cyclohexane. Clear? Okay. What we have here? Also, we have another example. 1,2 dimethyl cyclopentane. Okay, why we use now 1,2? Why we put number? Why we put number? 2 substituent, more than 1. If you have 1 substituent, we don't need number. But if you have 2 substituent, okay, where is the 2 substituent? 1, 2, 1, 3, 1, 4. That meaning here in this example, it will be 1, 2. Okay, in this example, it will be 1, 2, and so necessary to put the number here. Okay, don't go like this. 1, 2, 3, 4, 5, 6. No, it will be false. Okay, 1, 2, 3, 4, 5, 6. It will be 1, 2. Give the second substituent lower number. So this, look here. It will be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. No, we have different here. Okay, if you use here 1, 2, 3, 4, that meaning 3, 4, it will be for the second and third substituent. 1, 2, 3, 4. Okay, look here. Number to give the second ethyl group the lower number. That meaning if you go to 1, 2, 4 like this, 1, 2, 3, 4, not 1, 2, 3, this 3 and 4. Okay? Tamam? Diamond, give the second substituent lower number. So, give a IUPAC name for each compound. This homework for you. What is the name of this, for example? For this, if we have methyl, and we have what here? Methyl, ethyl, propyl, butyl. Okay. 1. Okay, good. 3 3, 3. That meaning if you have identical group, you have to duplicate the number. 3, 3, dimethyl. Okay, we use di here. Dimethyl cyclohexane. Tamam, good. What is the name of this? 1, 2, 3. Trimethyl. Okay, we have used di, tri, tetra. Okay, tri, tetra. Tamam. This example, this it will be the parent part. That meaning you have to use number. Why? Because the cyclohexane, you don't know it at carbon number 1, low 2, low 3, low 4. Echo group, not that if you select this, the parent part, you don't need number. Okay? You don't need number. For example, I will give you example. If you have this, now, this is what? Ethyl cyclohexane. Okay, if you put this here, the same compound, her ethyl cyclohexane. Okay, but here different. Here, if you put this cycle here, look, 1, 2, 3, 4, 5, 6, like that. If you put the cycle here, it will be different here. It will be with this carbon number 1, this carbon number 2. It will be at the 2 because this is the parent part now. Okay, you have to say 2 cyclohexyl and the name of the alkane. Okay, so if you dicobab, the parent, the cycle, you don't need number. But if the parent part, the alkane, the open chain, you need number here. Okay. Now, give the structure corresponding to each IUPAC name. You have here IUPAC names, convert to the structure. This is homework for you. Okay. Do you have a question? Do you have a question? Okay. Angle, strain, cycloalkane. Now, what meaning the angle strain? Zawi, yes. الشد الزاوي, the angle strain. In tetrahedral figure, this is the tetrahedral figure. The sp3 hybridization carbon atoms that has tetrahedral figure geometry, yes, the geometry for the sp3, they are what? Tetrahedral figure. So, this here carbon we have here and like that. Okay. Now this the angle here is 109.5 degree. Also the angle, this the angle here, the same. The angle here, the same. The angle from here to here, also the same. Okay. This the base angle. They will be put all the group in the space, and it will be more stable conformation for the sp3 for the tetrahedral figure by the angle 109.5 degree. Okay. Any change to increase this number or decrease this number, it will be change the stability of the compound. Okay. That meaning if I want to make this and this closer, that meaning it will be decrease the stability for the compound. If I want to open this from here to open like that, also it will be decrease the stability of the compound. That meaning this is the normal angle, for example, this is the normal angle. If I want to decrease, also it will be affect the stability of the compound. If I want to increase the angle, also it will be the stability of the compound. Okay, this it will be called here the angle strain. Angle strain. In normal figure, it will be like that. But if I want to change it, it will be I have strain here. Okay, shed zawi. Okay, that meaning every effect to change this number for this angle to increase or decrease this from this number, it will be affect the stability of the compound. Okay, it will be affected to the stability. Okay, it will be changed the number. Okay. No, without any number. For example, if I change this angle from here, for example, to the 120, it will be effect to the stability of the compound. Okay? If I want to make this closer for مثلا 60 degree, also it will be effect to the angle, to the stability of the compound. Okay? So step by step here, but this is the idea. Okay? This is the meaning angle strain. Okay. Hard work. Both, yes, the stability will be affected. Okay? The stability will be decrease the stability. Decrease the stability. Both of them, yeah. Both of them. So, step by step, but this is the idea. What meaning the angle strain? This is the angle strain. Okay? This is the angle. Normal angle, this 109.5 angle. If I want to change it to closer or to open, to increase this value for the angle, to increase this value, decrease or increase this value, change this value, it will be effect to the stability of the compound. Yes, decrease the stability of the compound. Yes, decrease the stability of the compound. So, beside torsional strain and steric strain, what meaning torsional? Torsional, do you remember the eclipse-Stigard conformation for the alkane? Yes, that meaning we have Stigard and eclipse. If the eclipse, that meaning all the groups, they are aligned to each other. Okay, or the group, and the Stigard will be like that. Yes, eclipse, Stigard, eclipse. Now here the torsional يعني برمة. Okay, torsional strain. Here also affect to the stability of the compound. Now, anyone is more stable, the eclipse or the Stigard one, if you remember? The Stigard figure, the Stigard conformation. Okay, the Stigard conformation is more stable than the eclipse. Why? Because the steric effect between the groups. Because the steric effect between the groups. Not our subject now, but this is the idea. What meaning the torsional? The torsional strain and the steric strain. Okay? Torsional يعني برمة. That meaning if you have, for example, I don't take it my any مثلا this, for example, this. If I take this, okay, torsional strain, this is the torsional strain. Okay, torsional strain. Yes, torsional strain. And the steric strain, if we have here substituent group, and this substituent group, they are closer to each other, we have a steric effect. You know the steric effect, yes? But the torsional, this is the torsional effect. Okay, the torsional effect here. Thank you. Yeah, تعوج. Okay. So, angle strain is an increase in energy. Look, an increase in energy. What meaning increase in energy? يعني stability what? Decrease. Yes? Decrease the stability, increase the energy when tetrahedral bond angle deviate from, can be changed from what? From the optimum angle is 109.5 degree. Any change of this value, it will be decrease the stability of the compound. Okay? Of the compound. So, originally cycloalkane were thought to be flat ring. Okay? Firstly, they said all the cycloalkane in the same plane, in the flat. We say the flat. يعني that means all the carbon atom, okay, on the carbon in the past. This is in the past what they thought. Okay, all the carbon atoms in the same plane. Okay, in the same plane. But this also wrong, not so يعني right. So in the flat ring, what meaning flat ring? يعني at all the carbon atom for the cycle in the same plane. Okay, at the same plane, at the one plane, which the bond angle between carbon atom determined by the size of the ring. That meaning, if I say to you, this angle here is 60 degrees, that meaning your cycle is big cycle or small cycle? Small cycle, because the angle is now decreased from 109.5 degrees. Yes, but if I want, for example, this here, the cycle is 90. The angle here, the value of the angle here is 90 degree. That meaning this 90 degree more than 60, the value. That meaning the cycle here is bigger than here. Okay? Also the same thing. If I say to you the angle here between this carbon and this carbon, it's 144 degree. That meaning this cycle is small cycle or big cycle? Big cycle. Okay? This in the past, this theory here, this theory called barrier strength theory. Okay, this theory called barrier strength theory. The theory said all the carbon atoms at one plane, but in the fact, this is not right. Okay, in the fact, it is not right. Okay, but as theory in the past, or they said all the carbon atom at one plane. Okay, at one plane. So again here, where is it? It was assumed that the ring with bond angles so different from the tetrahedral bond angle would be very strained and highly reactive. Here, it will be very strained and highly reactive. Look, I opened the angle. That meaning we have strain here. Okay, we have strain here. This is called barrier strain theory, and this theory they had weak point according to the why all the atoms in the same plane, but in the facts is wrong. So it turns out about this theory, they related this theory, okay, so that the cycloalkane with more than 3 carbon atom, okay, in the ring are not what? Are not flat. Look, it is not flat. It is not flat. In the fact, it is not flat. Okay, so where is it? Just the cyclic with 3 carbon atoms, it will be flat, and more than 3, it will be not flat. So both the angle strain and the torsional strain, it will can be affected here. The 3-dimensional structure, this is the 3-dimensional. Look here, 1, 2, 3, 4, 4 carbon atom here. 1, 2, 3, 4, 4 carbon atom. Okay. Dimensional structure of some I can showing here. Look how many carbon we have here. 1, 2, 3, 4, 5. Okay, here 1, 2, 3, 4, 5, 6, 7. Okay, 7. Look, it is a flat. No, it is not a flat. It is not a flat. So 3 and 4 member ring is still a process considerable angle strain, but packing reduce the internal bond angle in large ring. That meaning we have what we have here. We have packed يعني تعوجة. Okay, we have here like that. Okay, like that it will be, yes, it will be go not in the plane. It will be go out of the plane to increase the stability of the compound. Okay, to increase the stability of the compound. So if I say to you here, look to this homework, this is small homework. Rank the following compounds in order and increase what? Stability. Based on what? Based on the relative ring strain, just like that. Okay. If I say to you this three cycle, okay, 3-member cycle here, and this is 4-member cycle, and this is 5-membrane cycle. Anyone, it will be more stable one, more stable one, more stable one. Look, here the 3 is the less stable one, and the 4 is more stable than the 3, and the 5 is more stable than the 4. Why? Because the angle value here is near from 109. Here the 60 degree is so far from the 109.5. So that meaning this, it will be decrease the stability here. Okay, here the angle, for example, 90 is near from 60 to this value, to the 109. Okay, to the 109.5, it will be more stable than this. Okay, and here it will be near from both of the compound to this value. It will be more stable than this. دائما طلبة, when the value near from this 109.5, the stability it will be what? An increase. The stability it will be an increase. The stability it will be an increase. Do you understand? Do you understand? Okay. The way that is hot. Now, the chair conformation of the cyclohexane. Actually, inshallah, in the next lecture, I will take my tools to show you how the chair of the cycloalkane, it will be happen here, the cyclohexane. Inshallah, next lecture. But here we take just small introduction about the chair conformation. Okay. What meaning chair? Chair, yeah, no, the kursi, chair conformation. So a planar cyclohexane, this is the planar cyclohexane ring, express the angle strain here to the 120. Okay, look, more than 109. That meaning is less stable than the fact cyclo, the chair form. I will give you step by step. So, and torsional strain, because all the hydrogen on the adjacent carbon atoms will be eclipsed. If we say this is the real conformation of the cyclohexane in the flat, okay, in the flat, for example, this in the same plane, okay, in the same plane, like that, at the same plane, that meaning all the hydrogen, it will be what? All the hydrogen, it will be eclipsed to each other. This hydrogen, it will be eclipsed to this, and this hydrogen, it will be eclipsed to this. And you know, eclipse, we have here more what? Steric effect here. If this hydrogen near from this hydrogen, and this hydrogen near from this hydrogen, we have a steric effect here. A steric effect, and the steric effect, it will be decrease or increase the stability? Huh? Decrease the stability. Okay? It will be decrease the stability. So, decrease the stability. Look here, it is clear for you. Look, this hydrogen we have here steric effect here, steric effect here. This is decrease the stability of the cyclohexane if we say the cyclohexane at the same plane. But in the fact, the cyclohexane not at the same plane. Okay? Not at the same plane. In reality, the cyclohexane adapts to this packed conformation. يعني بشكل يعني like that, okay? Like مجعد, okay? Like that. So, colored chair form. It will be colored chair form, which is more stable than another possible conformation. This the chair form. Look, this the chair form. It is like chair, بالضبط, like chair. كرسي. Okay, the chair form. By chair form, this is the hydrogen here. It will be what? It will be not eclipsed to each other. Not eclipsed to each other. So also the angle, it will be near from this 109.5, not like near from 109.5, okay? Near from maybe exactly it will be 109.5, okay? Will be so. So, by this conformation, the hexane, the cyclohexane, it will be more stable figure than a planar cyclohexane, okay? Than planar cyclohexane. Do you understand? Inshallah, next lecture, I have my special tool to show you how the chair form will be changed. And it will be give you more stable conformation. The chair conformation here, look, chair conformation is so stable because the eliminate angle strain, there is no angle strain here. The angle here between this carbon and the carbon, it will be exactly to the 109.5, okay? That meaning we don't have angle strain here. We don't have angle strain here, okay? So the carbon-carbon bond angle are 109.5. Like tetrahedral figure, like the angle in the tetrahedral geometry. So we don't have angle strain here. We don't have angle strain here. And torsional strain, there is no torsional strain. Why? Because all the hydrogen, they are staggered to each other, not eclipsed to each other. They are staggered to each other. Okay? They are eclipsed to each other. For example, if I want to show you this, give me this, please. Okay. Now, for example, this is the planar cyclohexane. I want to convert it to the chair. It will be like this. Okay? Chair form. This is the chair form. Chair form. This. Okay? Chair form. So, inshallah, next lecture, I will show you how the chair form will be, and the cyclohexane will be formed by the tools we use to explain for the students. So, in cyclohexane, the 3 carbon atoms packed up, and the 3 carbon atoms will be go to the down. Okay, go to the down to the plane. That meaning, if I say to you, this is the plane here, this is the plane of this molecule, this is the plane. That meaning, this carbon and this carbon and this carbon, it will be up to the plane. 3 carbon atoms, and another 3 carbon atom, this and this and this, it will be down to the plane. of the molecules. Okay, 3 atoms up to the plane and 3 atoms down to the plane. Look, this with the black color up to the plane, and with white color it will be down to the plane. Okay, this is the chair form. So each carbon in cyclohexane has 2 different kinds of the hydrogen. This carbon has 2 hydrogen. Yes, 2 hydrogen. But the position in the space of the geometry, it will be different here. We call it, one of them is axial, and the second it will be equatorial. Now, what meaning the axial hydrogen? What meaning equatorial the hydrogen? Again, if this is the plane of the molecules like that, this is the plane of the molecules. Okay, the axial hydrogen will be up and down to the plane, up and down to the plane. If your plane like this, the hydrogen axial, it will be on this side and on this side. Okay, the axial hydrogen. You understand? This is the axial hydrogen. And the equatorial hydrogen, it will be with the plane of the molecule. That meaning if your plane like this is the hydrogen, the equatorial hydrogen. Equatorial hydrogen, equatorial hydrogen, equatorial hydrogen, equatorial hydrogen, like that. If your plane like this, where's the equatorial? Equatorial hydrogen, equatorial hydrogen. Do you understand? So دائما equatorial hydrogen with the plane of the molecules, But the axial hydrogen, يعني محورية, it will be perpendicular at the plane of the molecules. Do you understand? So here again, axial hydrogen are located above and below the ring. Okay, بينما equatorial hydrogen are located in the plane of the ring, with the plane of the ring, as we show you here. This equatorial hydrogen, but this is axial hydrogen. Every carbon until here, all of them, all the carbons, they have 2 types of the hydrogen. One of them is equatorial, and the second hydrogen is axial. This in any conformation is the chair form, okay, not in the flat form, in the chair form. Do you understand? So to the next lecture, inshallah, I will stop to here to the ring flipping. Okay, how the ring it will be flipped to convert one chair form to another chair form. Inshallah, to the next lecture, we will talk about this subject. So, do you have a question? Okay. If you have a question, I am ready.